So we have our isolated connected branches to the trunk, and next thing we should do is build bounding box per each trunk, per each branch, build a matrix and apply inverse transform to align these branches along one axis and apply UV. For this, create a for each primitive loop, and we use a class here. So now we have one branch. Let's create a bound. Use oriented. So now we have an oriented bounding box. And let's create a point triangle. Oops. Point triangle. Yeah, and start building a matrix. So for build a matrix, we will use a neighbor function. The neighbor function take a point and look in all neighbors connected through the edge. So point 3 have a 2, 0, and 7. And then we load each position of these neighbor points and create the vectors along the edges. And we will find the longest edges, and we will use this axis for all branches to align in one direction to get one direction UV on our branch. Let's start. Type here integer PTS. So we create an integer PTS array where we store all these neighbors point and use neighbors function 0 at pt num. So it's looking in first input across all points. So each point has an array of points connected to each other. Let's create a float lists array where we store length of each edge. Then create a vector dirs array where we store the vectors along the edge. Let's create a for each loop integer pt in PTS. So we will looping through each array per each point. Let's create a vector pos equal point. So we allow the position of first neighbor. And then we create a vector dir equal pos minus our current point position. So we should create vectors directed from this our current point to neighbors. So we should subtract this from this position, and get this directed direction vector. Next, we create a float dist is equal length of our dir. And now we have a vector, we have a length of the vector, so let's save them in the array. We will use an append function. Append function push value to the array and increment its size for 1. Use dist array and our dist, our length of this vector. And second, append our dirs, and we will normalize our dir, because to build a matrix we need a normalized vector. Yeah, so we have per each point we have a two arrays with vectors and length of this vector. And now we need to find the longest one. To find the longest one, we sort the lists in increment manner and use indices of this array to reorder this array accordingly to the lists that we have a longest age and longest vector in the same indices on the different array. For this, use a dirs equal reorder. Reorder function take indices from one array and sort another array according to these indices. This will be dirs, and we use arcsort function, the arcsort function, sorting indices in the array in the incremental manner, and this will be our lists. And the longest vector in this array, it's a last item in array. So let's create a vector z, and it's equal dirs -1. So it's -1, it's the latest array value. And let's take first one, vector y equal dirs 0. So now we have two vectors. Let's create a third one, vector x equal cross of our z and y. I'm not loading the third one because we need a perpendicular third vector, and in here it's all vectors perpendicular of each other, but in other situation when you can use this script, it's possibly not be perpendicular, so I use a cross to double check that everything is correct. And let's create a matrix M equal set x, y, and z. Now we have a matrix, but this is 3 vectors, so it's a matrix 3, but we need a matrix 4. So we need to store the position of each point. For this, we will use a translate function. Translate function, our matrix M and our position of each point. And let's save it on our points. For M equal M. Now each point has a matrix. Let's visualize it. Visualize. And it's a marker axis and our M matrices. So now you see each point has a matrices and the axis looking along the longest edge. So in next video we will apply invert transform and create a UV for our branches.